Dear students, as I explained to you in previous video, decision tree algorithm. So now let us understand algorithm more briefly with a proper example. Now, this is our data set. Now the last column is indicating me class label, and these are the four features. And now I want to find out which feature is the best feature that I can place at the root level of my decision tree. Now I'm applying ID3 algorithm that uses max information gain. Information gain is depending on entropy. Now I need to calculate entropy for entire data set as well as I need to calculate the entropy for each individual feature so that I can find out the weighted average of that entropy. Now let us find out entropy for entire data set, which is known as E of S. Now in your entire data set, that is in the last column, find out how many yes are there and how many no are there. Now, when you count, how many yes are there? 9 yes are there. So the probability of your positive class is 9 by 14. Means out of the 14 observations, I am having 9 observations as yes. So I will take the probability as 9 by 14. I am having remaining 5 observations as no. So I will take its probability as 5 by 14. Now it will be multiplied by its log, then it should be added, and you have to take the negative value of this summation, and finally you will get the entropy of entire data set as 0.94. Now what I should do, what is my next step? I should calculate the entropy for each feature to find out the weighted average of these features. So out of 4 nodes, which node I should select? Okay. Now, let us start one by one feature. Now, the first feature is what? Outlook. What is my first feature? Outlook. Now, what are the possible values for Outlook? Sunny, overcast, and rainy. Okay. Now, how many sunny values I am having? 5 sunny values. Out of 5, 2 are yes, 3 are no. How many overcast values I am having? 4, out of which all are yes. Means the probability will come 4 by 4, that is 1. And the entropy will be what? Low in this case. Okay, because it is the most pure data set, the most pure subset of my data set. Now, for rainy, what is happening? 5 rainy values are there, out of which 3 are yes, 2 are no. So the rainy is exactly opposite of sunny. 2, 3, while here 3, 2. So remember these values. Okay. Now, how I am calculating the entropy of a sunny? How many total sunny values are there? 5. Out of which how many are positive? 2. How many are negative? 3. So this is the entropy for sunny. This is now in overcast. What is happening? 4 values all are positive and 0 negative value. Okay. Now for this, I'm getting the entropy as 0. I told you that it is the most pure subset of my data set, which is having all the yes values, and that's why its entropy is low, that is equivalent to 0. Now for sunny, 3 are positive, 2 are negative. So I will get the entropy as 0.971. Okay. Now I should find out the weighted average. Now 5 by 14, because the 5 sunny values, again 5 rainy values, and 4 overcast. So I will get the weighted average as 0.693. Now this should be subtracted from the entropy of whole data set, and finally I will get the information gain as 0.247. So 0.247 was the information gain for Outlook. Now let us move to the next feature. Next feature that I am selecting is windy, in which the possible values are true and false. Then how many true are there? 6 trues, out of which 3 are yes, 3 are no. Okay, means it is equal. That is the most impure. Okay, then in such cases the entropy should be 1. We have seen that one. Now here what is happening? Um, these are the false values, and out of which only 2 are no and the remaining all are yes. Now, when we are calculating the entropy of windy is equal, that is true, is equal to 1, because what is happening here, for true equal yes and no values we are having, that's why we are getting it as a 1. Now for false, when we are applying it, the formula of 6, for false option, out of the 8 values, 6 are yes, 2 or no. So by applying that positive and negative probability, what we can do here is we get the entropy of false option as 0.81. Then when we are applying the weighted average of it, we get the 0.892. Okay, and now that should be subtracted from the entropy of whole data set, and 0.048 is the information gain of wind. Okay, now in the same way, when we calculate the information gain for temperature and humidity, then we are getting the 0.029 and 0.152. And these two we have already calculated. Now, when we are observing value, Outlook is giving me the maximum information gain. So I can take Outlook as a root node. Now, Outlook is having what different values? Sunny, overcast, and rainy. So that will come as the next level nodes. Now, the overcast will not have any sub trees. Why? Because it is having all yes options. So there will be no sub trees for it. But we will have the subtrees for sunny and rainy. Okay. So again, calculating the information gain for the available option should be repeated, and we will get the final decision tree. So this is what the ID3 algorithm. So like this, we will get. Now, as an assignment, I'm expecting from you all to calculate the decision tree for this given data set. Okay, so this is the final class. Now, what is the question here is, I want to find out whether a particular batsman is hitting 6 or not. Okay, so this batsman is belonging to Chennai Delight team, and whether he is hitting 6 or not, that we have to find out by applying ID3 algorithm. Okay, so we have to construct a decision tree. Now, how you can start? In explain the example, we were having 4 features. Here, how many features we are having? 5 features. So for each of these feature, we have to find out information gain. Now, suppose I start with where. Then for where, what are the possible value? One is a home and second one is a away. Okay. Now for home, how many yes values are there and how many no values are there? That you have to find out. Then you will get the weighted average of it. But before that, you have to find out the entropy of entire data set. So how many yes values are there and how many no values are there? Based on that, find out the entropy of entire data set, and from which subtract the entropy of this weighted average. Then you will get the information gain of where. So the same procedure should be repeated for remaining 4 features. And finally, you will get one feature with the maximum information gain, and that will become the root of your decision tree. So like this, we can apply the ID3 algorithm for any data set. If you understood the explained example, you can easily apply it on any given data set. Okay. Thank you.